Assalamualaikum and hi everyone. Today let's talk about our project. The name is Design and Calibration of a Pressure Sensor Monitoring System using Multimeter, Oscilloscope and LabVIEW. So let's talk about team member. I'm Haikal Haziq bin Suasnat and we have Ahmad Darwish Firaj, Akif Hakimi and lastly Intan Anis Akasha. So the introduction of our project is this project designed a pressure sensor monitoring system using an FSR sensor. The sensor converts applies pressure into a voltage signal through a voltage divider circuit. This signal is measured using a multimeter and oscilloscope and analyzed in real time by using LabVIEW with DAQ system.
So objectives for this project, firstly to design a pressure sensor monitoring system using FSR. The objectives of this project is to design and develop a functional pressure monitoring system using a force sensitive resistor, or we call FSR. This includes understanding the working principle of the FSR, where its resistance changes according to the applied force of pressure. The system will be integrated with basic electronic components such as resistor, possibly a microcontroller to convert the resistance change into a measurable electrical signal. Emphasis is also given to circuit design ability and ensuring accurate signal transmission for monitoring purpose. Second, to measure and observe sensor output using multimeter and oscilloscope. This objective focus on analyzing the output signal generated by the pressure sensor. A multimeter will be used to measure the DC voltage level corresponding to different applied pressure, while an oscilloscope will be utilized to observe signal variation in real time. This allows a deeper understanding of how the sensor behave under different conditions, including signal fluctuation, noise, and response time. The use of this instrument help improve practical skills in handling electronic measurement tools and interpreting data accurately. Next, to calibrate the sensor by relating pressure to output voltage. The purpose of this objective is to establish the relationship between the applied pressure and the output voltage produced by the sensor. Calibration is performed by applying known force to the FSR and recording the corresponding voltage outputs. The collected data is then used to plot a calibration curve, which helps determine the sensitivity and accuracy of the sensor. So this project is important to ensure reliable measurement and to convert raw voltage reading into meaningful pressure values for real-world application. For the study from Malaysia, the title is Design and Calibration of a Pressure Sensor Monitoring System. This means the study focus on design a pressure sensor system and also calibrating the sensor so that the reading become accurate. So the method, they use the concept of a voltage divider circuit with a force sensitive resistor, or we call FSR, and connect it with an Arduino Uno and LabVIEW. Firstly, the voltage divider is used to convert the change in resistance from the FSR into voltage. After that, the Arduino reads the voltage. And lastly, LabVIEW is used to display and monitor the data. For the sample size, they use 4 units of FSR 402 sensor. This means
The title is Characterization of Force Sensing Resistor is FSR. The method is measurement of resistance change Vs applied force using PTF technology and sample size single Vs array configuration. For the comment is highlights the non-linear nature of FSRs and the necessity for the mathematical compensation in software.
Literature review for Germany for title Industrial Automation Monitoring System. And method for Germany is integration of LC and DAQ system for real-time monitoring. For sample size in multi-sensor integration, and the comment for Germany is emphasize the sensor stability is affected by hysteresis and environmental factor like temperature.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hakif Hakimi. In our literature review, we analyze several international standard with a particular focus, research from Japan. The Japan study, titled High Precision Instrumentation and Calibration, utilizes a 4-channel input, the analog input for its sample size. The method involves a direct comparison of digital data acquisition (DAQ) readings against standard manual instruments like multimeter and oscilloscope. The key finding from this region confirm that validating digital data with manual instruments is crucial for achieving industrial grade accuracy. This research justifies our approach of using both LabVIEW and traditional meter to ensure our sensor data is reliable. In next slide is circuit diagram. Now let's look at the circuit diagram. Our design incorporate 4 separate FSR sensor, FSR1, drop FSR4. Each sensor is integrated into a voltage divider circuit. The primary purpose of this circuit is to convert the changing resistance of the FSR, which happens when pressure is applied into a variable voltage signal. This voltage output, labeled FSR 1 volt, top FSR 4 volt, are then fed into the AQ system for process. Nextly, list of components. To boot the system, we utilize the following components: 4 FSR 402 sensor. These are used to detect physical pressure force such as weight or torque. And next, 4 resistance 10 kilo ohm. These are essential for building the voltage divider circuit that convert resistance to voltage. Next, Arduino Uno. This as our main interface board and the AQ unit, converting analog signal into digital data. Nextly, breadboard and jumper wire is connection. This allow us to connect the sensor and resistor without the need for soldering. Next, software is LabVIEW and Link software. This is used to process the data, perform the actual calibration, and display the result via a GUI. GUI is graphical user interface. Nextly, instruments: multimeter, digital, and oscilloscope. We use this for manual validation and to monitor signal stability and electrical noise.
Assalamualaikum, my name is Intan Akasha. Today I want to present my slide. My slide is block diagram. Okay, first we start with detection stage, where the sensor acts as the input device. It detects the physical parameters such as pressure or voltage from the environment. And then for signal conversion stage, the raw signal from the sensor is converted into a usable electrical signal, typical into a voltage range like 0 to 5 volts. And then we go to data acquisition system, DAQ, where the analog signal is captured and digitalized so it can be processed by the computer. And then we have measurement and validation stage, where the system check the accuracy of the data by comparing it with standard of reference values. And then the final is processing and display stage. The results are displayed in graph or numerical from using software such as LabVIEW. For data collection plan, for voltage measurement, we use the DAQ analog input method. The expect signal is an analog DC signal between 0 to 5 volts. The data will be presented in a graph of voltage versus time. To ensure accuracy, we compare the DAQ reading with digital multimeter. And then for resistor measurement, we use digital multimeter. The expect signal are the correct values. The graph plot will be resistance versus load, and the results are compared with the sensor datasheet specifications. And for the last one is pressure measurement. We use LabVIEW algorithm to process the data. The expected signal is linearized signal. The graph will show pressure versus voltage, and we compare the result with standard weight to validate accuracy.
Nextly, project scope and limitation. Finally, we must address the scope and limitation of our project. Scope: our project focus especially on static calibration within a controlled laboratory environment. Furthermore, the monitoring is limited to a single pressure point is one FSR sensor at the time. Limitation: we have identified three primary challenges. Firstly, hysteresis. This is the sensor may provide slightly different reading when unloading pressure compared to when it is being loaded. Second, temperature sensitivity. FSR resistance can vary based on the ambient temperature, which affect long-term accuracy. And lastly, non-linearity. Since FSR are inherently non-linear, we must implement mathematical compensation within the LabVIEW algorithm to ensure high pressure result. This slide reference, we use voltage divider theory, and second force sensitive resistor, interlink electronic, FSR integrated guard. Next, Arduino official documentation. LabVIEW overview, National Instrument Data DAQ system. That's that all for me. Thank you.